Whatever happened to predictability? The milkman, the paperboy, evening TV.
Hey ladies and gentlemen, today we're going to talk about greatest common factor. You maybe have heard the acronym GCF, and that stands for greatest common factor. You're going to need your notes out in front of you and be ready to go. GCF probably is not new, but I'm going to teach you a new way to go about finding the GCF. Let's start by defining greatest common factor, also used by the acronym GCF. GCF is the largest factor two or more numbers share. When you were in elementary school, I bet you went about finding the greatest common factor by listing the factors for whatever numbers you were given. So I'm going to model that for you now, just to refresh your mind. This part right here, listing factors, is not in your notes. So please just watch right now, talk out loud with me as I work through this. Let's list the factors of 56. Now this time, 1 and 56 will work as factors because we're not trying to find prime numbers or anything like that. So again, we're just listing factors. We want to include 1 and 56. Anything times 2? Yep, 2n. And if you don't remember, could you use this tool? Absolutely. If I don't know what times 2 is 56, I could go 56 divided by 2, and I see that my calculator is showing me 28. So that means 2 times 28 is 56. Anything times 3? Well, 5 plus 6 is 11. 11 is not a multiple of 3. We do not have divisibility, so 3 is not a factor. How about 4? If you're not sure, you could go 56 divided by 4 on your calculator. Comes out to be a whole number. So 4 times, how about 5? Doesn't end in a 0 or 5. How about 6? No. How about 7? Yeah. 7 times 8 is 56. How about 8? I already have it on there. Repeat, we're done. So now let's find the factors of 42. Let's list them out. Again, I list mine in multiplication problems. If you want to list it outside the side, that's completely fine. So starting with 1 times 42, those are factors. Anything times 2? Yeah. 2 times 21. And if you didn't know, you could go 42 divided by 2 in your calculator, and you'd see that that's 21. Anything times 3? If you're not sure, use your divisibility rules or your calculator, multiplication chart. 4 plus 2, if I add up the digits, is 6. That's a multiple of 3. We have divisibility. So 42 divided by 3 is 14. So 3 times 14. Anything times 4? I don't think so, but if you're not sure, go ahead and check it out. 42 divided by 4, 10 and a half. I have a remainder, so no, 4 is not a factor. Anything times 5? Doesn't end in a 0 or 5. Anything times 6? Yeah, 6 times 7. Anything times 7? I already have it on there. I'm done. So then you went through when you were in elementary school and you said, hey, which one is the biggest that they share? They share 1, they share 2, they share 7, they share 14. So far that's the biggest, and that's what it is. So it looks like the GCF is 14. That's one way that you can find the GCF. I'd like to show you another way to find the GCF. So now we're going to dive into your notes. And we're going to go to the second chunk that says using or use prime factorization. Alright, so we are in the second chunk on your notes right now. And we need to find the GCF of 56 and 42 using prime factorization. I just modeled finding the GCF for these two numbers by listing the factors. Now I want to show you a new way. So looking at your notes, following the steps, the first step says factor each number. So let's start with that. Let's factor 56 using our tree. What two factors would multiply together to give me 56? I'm thinking 8 and 7. 8 times 7. Is 8 prime? No. Is 7? Yep, so I'm going to circle it. 8, I can factor that to be 2 times 4. 2 is prime, 4 is not. I can factor that to be 2 times 2. Let's go ahead and let's factor 42. Think of two factors outside of 1 and 42, right? Because now we're using prime factorization. We want to leave 1 out of it because 1 is neither prime nor composite. I'm thinking of 6 times 7. 6 is not prime, 7 is, so I'm going to circle it. I can factor 6 down to 2 times 3, and they are both prime. Going back to my notes, it says write the PF. So I'm going to write the prime factorization for each one of these now. I'm going to put a little separating bar in. And remember, we want to do smallest prime to largest, so 2 times 2 times 2 times 7, double checking, 1, 2, 3, and then 1, 7. And then over here, 2 times 3 times 7, double checking, nice. The third step on here says find all the common primes and place them where the circles cross. Here are my circles. I know yours are more down below in your notes. Here's where the circles cross. So I want to find common primes, primes that they share. It looks like they each have a 2, 1, 2. So they share that 1, 2. I'm going to take it out of the PF. I'm going to place it where the circles cross. Even though there's 2 2's right here that I have slashes through, they share just that 1. So I just put 1 in the middle. Do they share anything else? Looks like they share a 7. So I'm going to take that out of the PF and put it where the circles cross. They do not share anything else. Then it says place the remaining primes in the circles. So I have 2 2's left for 56, and I have 1 3 left for 42. The last step to finding the GCF using prime factorization says multiply the common primes. My GCF equals multiplying my 2 primes that are in the center of the circle, 14. And that's the same answer we got when we listed the factors. So this is just one more strategy on how you can use prime factorization to help you with things in math.